Today's lesson's on measurements, and specifically how to use a metric ruler. That might seem pretty simple, but there are some tricks to know. So let's say we're going to measure the length of this blue strip, and we grab the ruler that's available to us, which would generally look like this. Notice one thing about this to begin with. The zero is indented. That's how most rulers are. Not all of them, but most of them. And it's one of the first things you always want to do is make sure that's lined up with the zero. The one end of the object you're measuring is lined up with a zero. For rulers that don't have an indented zero like that, for rulers where the zero is right on the edge, something looking like that, for example, you're probably best off not actually using that zero because the thing might have been stamped off to the bit aside. It might have been the edge got worn down a little bit. For that, you're probably better off moving the object and lining up with a 1, but then remembering to subtract 1 from your measurement. But in this lesson, we're going to be using rulers that are all incremented with the zero indented a little bit. That's how most rulers are. So, looking at this, what do you think? Like 18? Okay. Right off the bat, one problem with that is 18 what? So, 18 centimeters, of course. And look over here, you'll see that there's always this increment is on the scale. The unit is always on the scale you're using. And so a centimeter ruler has centimeters printed somewhere on it. Well, that'll be our first rule then. Rule number 1, always include units with your measurements. That's important. You need to know 18 what. Now, back to 18. There's something more wrong with that because 18 is a pretty vague measurement. 18 would be a perfectly good measurement for this kind of ruler, which you're not likely to find, but still. When you say 18 in science as a measurement, it means you're certain of the 1 and the 8 is your guess. It would look like this: 18, maybe 17, maybe 19. So 18 centimeters is a good measurement, but only for a crude ruler like this, one with not a lot of precision. We can do better than 18. So you're thinking maybe like, okay, 18.1. Well, 18.1 is better. It is more precise, and it looks like it's around that. And 18.1 would be a good measurement for a ruler that looked like this. We're certain of the 18 now, the 1 and the 8, and now we're guessing that 0.1. Someone else might say 18.2. Okay? But for this scale, which is incremented to the tenths place, we can be sure of the 18.1. And now we look even more carefully. You have to do this when using a metric ruler. And we see, 18.13, 18.14, something in that range. So now we're guessing in the hundredths place, because we can do that because we're certain of the tenths place. That's given to us. So, rule number 2, always read a scale one digit past what the scale is incremented to. And by that I mean, here's a scale. It's incremented to the tenths of a centimeter. That's what each of these little marks represents, a tenth of a centimeter. So our measurement, 18.13, goes to the hundredths place. You can't go past that. You can't say 18.132 and make 2 guesses. Only 1 guess. That's the standard procedure when using any kind of measuring device in science. We know all of the digits except for the last one. The last one is our approximation. So, we're going to use these rulers now to make a few more. And you might want to try jotting down on paper, pausing this video and then jotting down on paper what you think are appropriate measurements. This time we're going to measure this yellow band. First with our very crude ruler. So write down what you think that is. And hopefully you put down something like 16 centimeters. Did you remember the unit? I hope so. That was our first rule. 16 centimeters. Right. And then you might have put down 15 or 17. Those are both fine. I think it looks more like 16. Judgment call. Okay? New ruler. Write down your new measurement. Now hopefully you realize it should be more precise. The previous scale was incremented every 10, so we made our guess in the ones place. We read it 1 past. This one's incremented every 1, so we should be guessing in the tens place. So what? 50, it isn't 16, it's like a little less than 16, so maybe 15.8 centimeters? Is that what you put down? Good. Now, here's the metric ruler you're more likely to be using, so let's go right to this one. And now again, I'm going to say, unless you really get close or get out a magnifying glass and see what that really looks like, you're not going to make a good measurement. It takes some time to make good measurements. So now we see it's not quite 15.8, it's 15.7, and we're certain of that. And then we're going to guess maybe 9. Is that what you guessed? 15.78. It's somewhere in that range. Okay? That's our measurement for the yellow band. Okay? Let's try another one. How about this green band? Okay, first with our very crude, not very precise ruler. Go ahead and write that down. Are you thinking 22 centimeters? Good. It's hard to gauge because there is no 30 there, but we can judge it based on the distance between 10 and 20 and just kind of extending it from there. But we put the next best ruler up there. No, it actually wasn't 22. It's 21 point something, and so we're guessing 21.4 centimeters. Good. And how about this last, most precise one? And again, let's zoom in there. Our eyeballing it was pretty good with 21.4, so what do we put down for our answer here? Because it's right on the 21.4 mark. Do we put down 21.4? That may look correct, but think about it. That's no more precise than the previous measurement. 21.4 in science means 21.4, maybe 21.5 or even 21.6, and this clearly is not 21.4-ish. We're certain of that 4 now, and we're guessing it's right on the mark. So how do we show that? Hopefully you're thinking 21.40. So we need one extra digit there, one extra significant figure in our measurement. And notice how they go 2, 3, 4 significant figures. That's what that 0 is all about at the end. It shows a higher level of precision, a more precisely known 21.4, 21.40. Is that exactly 21.4? No. No such thing as exactly 21.4. That would be 21.40000 on forever. And we don't have a piece of equipment that can go that far. That would be impossible. Okay? In fact, I'll put it to you right now that there is nothing in this universe that is exactly 21.4 centimeters long. And I can say that because there's no way to disprove that. What instrument are you going to use to prove to me that something is 21.4 zeros on forever? You can't. And for this, the best we can do is 21.40 and stop there. Okay? One more here, a little red band. Now that doesn't even make it to the 10, so we'll say like 8 centimeters. And that's about as imprecise a measurement as you can make because it only has one significant figure. It's our guess. 8, someone else might say 7, 9, probably not, but still, 8 is our guess. It's increment every 10, so we're reading to the ones place. Next ruler says, looks like we're pretty good. Looks like it's on the line. So again, we'd say 8.0 centimeters. Okay? So what about this next one when it looks like it's still right on the line? Go ahead and write down what you think is the answer for this one. Well, I'm hoping you realized I've got to go one place past and say 8.00 centimeters. Notice, every one of these measurements we're making with the blue scale goes to the hundredths place. It has its guess there because the scale is incremented to the tenths and our rule says read one place past what it's incremented to. So if it's incremented to the tenth, read to the hundredth. If we found a scale that went to the hundredth of a centimeter, we'd read it to the thousandths place, making our guess there. Okay, see, someone else might see that as 8.01 if it was just slightly past it. Okay, it's a judgment call.